Hello everyone and welcome back to the course. In today's lesson, we're going to deal with a generalization of the idea of periodic functions. Today's lesson is going to be about sinusoidal functions. As we mentioned before, all periodic functions have some qualities that are very important. Those qualities are the amplitude, the period, and horizontal and vertical transformations. As a matter of fact, both the functions sine and cosine satisfy the following equations, which represent horizontal translations. Thus, we can say that both sine and cosine have pretty much the same behavior. Let us define what a sinusoidal function is. A sinusoidal function is a function which it is based either in the function sine or in the function cosine. Thus, every sinusoidal function has the following form. f of x equal a times sine of b times x plus c plus d, or a times cosine of b times x plus c plus d. Now, the parameters of every sinusoidal function represent the specific qualities of every periodic function. For instance, the parameter d represents the midline of the periodic function, and this is gotten by taking the average between the minima and the maxima. The parameter a of the sinusoidal function represents the amplitude of such a function, and this is gotten by taking the distance from the midline to either the maxima or the minima. The parameter c represents the horizontal shift of the periodic function, if any, and the parameter b is extremely related to the period of the sinusoidal function, because if p represents such a period, then p is equal to 2 pi over b. Let us consider the following graph, the graph of a sinusoidal function, and let us deduce its equation. We will deduce its equation by deducing the parameters a, b, c, and d for either the sine function or for the cosine function. Let us start with the midline. We get the midline by taking the average between the maxima and the minima of that sinusoidal function. Now, the maxima is 6 and the minima is 2. Thus, the midline is equal 4. Now, the distance between the midline and either the maxima or the minima is 2. Thus, the amplitude a is equal to. Notice how the distance in x from one maxima 0, 6 to another 10, 6 is equal to 10. Then the period p is equal 10. Therefore, we have that the horizontal dilation b is equal to 2 pi over p. But remember that p is equal 10. Thus, b is equal to pi over 5. With the information we have, we can write that the graph is modeled by the sinusoidal function f of x equal 2 times sine of pi over 5 times x plus c plus 4. We need to figure out the value of c. Now, let us consider the function sine of x, and notice that it starts at x equals 0 and it increases until it reaches the maximum, forming a concave down shape. This specific description happens for our particular graph at x equals 7.5. Thus, c must be equal to minus 7.5 because C represents the horizontal translation. Therefore, the form of this sinusoidal function must be f of x equal to sine of pi over 5 times x minus 7.5 plus 4. Now, if we think of this function in terms of cosine, then we know that the function cosine of x as a sinusoidal function is equal to f of x equal to a times cosine of b times x plus c plus d. But the value of c representing the horizontal translation is different than the one that we got for the sinusoidal function in terms of sine. In this case, we have to think in the following way. In general, the function cosine of x reaches its maximum at x equal 0. And we're going to take this as a reference because our particular case reaches the maximum at x equals 0 as well. Therefore, this function hasn't suffered any type of horizontal translation. Thus, the value of c, if we think it in terms of cosine, must be 0. Therefore, the sinusoidal function in terms of cosine is as follows. Well, guys, that's it for today. Thank you very much for putting a lot of effort into this lesson. Now it is time for you to practice, and I challenge you to deduce the parameters of this specific sinusoidal function. And as always, see you in the next lesson.